In the last video, we talked about these conic sections, and I introduced a couple of standard forms to you. However, something to note is that these standard forms were for these particular shapes that I drew in black. However, the shapes can be different, and for example, this one, we know this is like an x equals y squared, and this would have to be represented again in this form: y minus k squared is equal to 4p x minus h. So you can see like a y squared equals a constant x, that form. The ellipse would also, if you see a is greater than b, and we would have the y minus k shifted in front and the x minus h there, this would give us an ellipse of this form. Then we have the circle, which remains unchanged because if you flip it or something or rotate it, there is no change. We have the hyperbola, which we had of that shape, but if we shift again the y and the x, we would get the purple curve with this equation. So you might come across these as the standard forms instead of the ones that I've shown, but they represent the same thing. You might also come across, well, we will definitely come across shapes like this, parabolas that are shifted. And in many references, you will find this as a form: y minus k is equal to negative 4p. However, we will not be using that. Instead, we will use the idea that p is less than 0 or p is greater than 0. So as we go forward, you will be finding these in the upcoming videos. In this video, we'll be talking about the general equation of second degree. And let's go ahead and have a look at that. For two independent variables, this is the general equation we have: ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. Here, a, b, c, d, e, and f, these are constants, and however, I will not be using this as the main equation. We can also have another form by just relabeling the constants. We can have ax squared 2hxy plus by squared plus 2gx plus 2fy plus c is equal to 0. We'll be using this form for some ease in the notation. Okay, so let's go forward and see how this is helpful. Okay, so let us define delta as abc plus 2 fgh minus af squared minus bg squared minus ch squared. This term would help us identify whether the equation we're dealing with, the general equation that we have, gives us a degenerate or a non-degenerate conic. So if you're wondering where this came from, let's have a quick look at that. If we have a matrix representation of this equation, it would look like xy1 multiplied by a matrix of the constants. We would have the constants a, g, h, h, p, f, g, f, and c. These ones multiplied by the column vector xy1. Okay, so this, equals 0. This is just a matrix representation of the second degree equation. And the delta is in fact just the determinant of this, this matrix of coefficients. This is the reason why we kind of used this form of the equation. Now, where would this be useful is when delta is equal to 0, we have a degenerate case. And we have like a like parallel lines or a straight line if this condition is satisfied. H squared minus AB is equal to 0. Now, where's this coming from? Let's have a look at that. In this equation, if we look at the discriminant, which is b squared minus 4ac, you can use now this equation to see what that comes up as. The b squared would give us like a 2h squared minus 4 ac, which is a here is represented into a and c is b here, so 4ab. So we have a 4h squared minus 4ab, and the constant there can be just kept outside and you have this form. We can then basically ignore this constant by dividing it to the right hand side. If it's equal to 0, well, of course, you know this is gone. And so that discriminant basically gives us this condition. Now we will have perpendicular lines. When we have a plus b is equal to 0. So just that condition that this constant and this constant have opposite signs. Now, if delta is not equal to 0, we do have a non-degenerate case, and we will have the parabola. So let's first perhaps look at, the parabola, where we have h squared minus ab is equal to 0. So when the discriminant is equal to 0, we have the parabola. When we have the discriminant greater than 0, we have the hyperbola. And when the discriminant is less than 0, we have an ellipse. So you can see how the general equation of second degree is giving us all of these as its results, depending on how the constants are given. So, but where's the circle? Well, the circle is going to further need another condition. If after h squared minus ab is less than 0, we have a is equal to b and h is equal to 0, and h is equal to 0, we will have the circle. Okay, so same condition, the discriminant being less than 0 and these two conditions being satisfied, the constants here in front of the x squared and the y squared, they're equal, and the h is 0, so this cross term is disappearing, we would have a circle. So now that you know these conditions, let's look at an example. Let's say we have this question that asks us what is represented by this following equation. We have a 5x squared minus 2xy plus 5y squared minus 8x minus 8y minus 8 is equal to 0. We must first compare it with our general form of the equation. And as you can see, well, we can simply go ahead and compare. The 2h is equal to this. The a is here, the b is here, the 2g is here. We have the 2f plus 2f is equal to negative 8, and we have the c, which is negative 8. So let's go ahead and write them down. A is equal to 5. We have h is equal to 2h is equal to negative 2, and so we have h is equal to negative 1. B is equal to 5. We have g is equal to, so 2g is equal to -8, and so we have a g is equal to -4. Similarly, 2f is equal to -8, so f is also equal to -4, and c is equal to -8. Okay, so now that we have our quantities, we can go ahead and calculate firstly delta, the quantity we had defined. So delta, as you remember, is ABC plus FGH. There's an easy way to remember this. AF, negative AF squared. Sorry, there should be a 2 here. Negative BG squared, negative CH squared. Now, if we calculate this out, we would have 5 multiplied by 5 multiplied by a -8 plus 2 f -4 gh. So we have a -4 again, h is -1, and you can go ahead and do the whole calculation, which will look like this: plus 8 into 1, and this gives us a -384, which is not equal to 0. So this means that it is not a degenerate conic section, it's a non-degenerate one. So we have delta is not equal to 0. And so now we can check the condition. Now, h squared minus ab. This is equal to, let's go ahead and see, h was -1, a and b are here. So -1 squared minus 5 into 5. So we have 1 minus 25, which gives us a negative value. So we have our discriminant is less than 0. And if you look ahead, look back and see, this was the condition. Well, we would have to check this as well. Well, here we can see a is equal to b. Okay, a is 5 and b is 5. However, h is not 0 here. We have a value for it. We do have a value for h. So this is definitely not a circle since it does not satisfy both of these conditions. And so we can conclude that therefore this equation represents an ellipse. You might have other constants relabeled, and you might be asked to find out which of these this represents. Why I introduced this topic early on is because, well, even if you do not have to convert, like you do not have to find the delta in certain questions, we will come across this sort of form instead of these nicely completed square forms.